All right, let's get started. My apologies before we begin. I think I mentioned this on Wednesday that I was dealing with a sinus infection. I thought it was getting better. Yeah, not so much. So I'm operating at about 60% speed right now, so my apologies. Okay, last homework prior to the exam was due today. I'm going to post the solution on Saturday for you all to study, but there obviously is no homework on Monday or no assigned homework today. I'm not assigning anything today, and I'm not assigning anything on Monday. So I just want you to worry about the exam, okay? Speaking of, just to make sure everybody's on the same page, this is our weight breakdown. One of the things I will do after exam 3 is I send out a spreadsheet. A buddy of mine in grad school, he called this playing the at-home game. What he would do is he would take like the attendance, the homework, the 3 exams, and figure out what he would need to get on the final to get a certain grade in the class. Called that playing the at-home game. So I have a spreadsheet that'll do that. So I'll probably send that out near the end. So just because. Okay. Each of the exams are worth 15%. So no one exam is really that, like meaningful on the grade. So I do that on purpose. So, okay. Any questions about the structure of the class? Because we'll get into the exam here in a second. Sound good? Okay. So, did everybody get the code, by the way? Everybody get the code? Okay. My purpose today is twofold. Okay. The first thing that I want you to do is I want you to know what the exam's going to be like in terms of its structure, content coverage, material coverage, and so on and so forth. I don't want you to come in going, well, I thought we were getting this, and then we got that. You know what I mean? Like, we thought we were doing problems, and then, oh, it's multiple choice. That always bugged me when I was a student. I wanted to at least know the type, what the exam was going to be like when I took it. So we're going to go through the logistics first, the format, what you can have on the exam, so on and so forth, and then go through what's on it. All right, so it's on paper, it's in here, it's not on Blackboard. I have always used a rule of 3 when I make exams, and so what that means is that I take the exam, and so the idea is that if I can do it in 20 minutes, you can do it in 60 minutes. Okay, so I take whatever time it takes me to take the exam, multiply it by 3, and if that's longer than how much time you have to take the exam, I will shorten the exam or adjust it accordingly. Okay, I will probably let the exam go till 11:55. Okay, but we have a class coming in here at noon, so I can't go that much longer. Okay, in terms of the content and what the exam is going to be like, there's going to be 4 to 5 short answer conceptual questions. When I say short answer, I mean short answer. And this is more really for your advice. For example, if I give you a short answer question and you are writing like 4 or 5 lines of text for a 5-point or a 4-point problem that you could answer with 3 words, answer it with 3 words, because all you're doing is subtracting time from the other problems on the exam. Okay? Like the idea is if I have a problem that's worth 25 points, you should be spending 25% of your time on it. Okay? That's more of a piece of advice for you. I'm not going to go nuts on grammar or anything like that. I'm just more interested for these if you're getting the concept right. And then there will be 2 to 3 computational problems, which, by the way, am I a partial credit guy? Yes. Okay? I am. Okay? I tend to deduct based on the proportion of the mistake relative to the problem. In other words, if you have everything right and 1 calculator error, that's going to be a few points off. That's not, oh, it's wrong. Whole thing's wrong. I'm not that guy. Okay? So just right there. It is closed book, closed notes. You're allowed a calculator. When it comes to the calculator, I really don't care what calculator you use, just as long as it doesn't have a Wi-Fi connection, like your cell phone. But I do strongly suggest that you bring a calculator that can solve 2x2 or 3x3 systems of equations. So, because that might show up. You can have a formula sheet. I want you to make the formula sheet, not me giving it to you. But I am giving you some guidance in this presentation. Okay, so that's kind of what we're doing here. One of the things I put here, and I put this on every exam, but I'll level with you, this is more important for like exam 3, a straight edge. Exam 1 and even exam 2 a little bit, it's not the biggest deal, but exam 3, having a straight edge really, really would help, okay? It's like a ruler or something like that. When it comes to the formula sheet, I want you to make the formula sheet yourself, okay? I don't care if, so here's my sort of rules for the formula sheet, because I'm gonna collect them after the exam. To be clear, I don't care if you use a software program to make it or you handwrite it, but I want you to make it, okay? In other words, I don't want you to screen capture some slides, put it on a sheet of paper and hit print, okay? I'm not doing that as a means of punishment. I have found that the process of actually making the formula sheet, you are studying, okay? And I'm telling you, there will be students taking this exam that don't even look at their formula sheet, because by making the formula sheet, you synthesize the thoughts in your head, okay? So I think that you should make it yourself, okay? Now, in terms of the one thing I don't want to see, I don't want to see a fully worked out example problem or a fully worked out homework problem, but that is more for your benefit than it is for me being difficult. What I have found when students do a fully worked out homework problem on their formula sheet is that numbers from that problem can sort of show up in your exam problem, and then it gets more difficult because you're like, where did this angle of 30 degrees come from? Because the problem didn't have 30 degrees in there at all. You know what I mean? And now the problem, you're chasing, it's like a dog chasing your tail because you can't figure it out because the number that you're calculating didn't come from the problem statement. So that's more for your benefit. I don't have a problem if you're synthesizing concepts or step-by-steps and things like that, but just copying and pasting a fully worked out problem from a homework or an in-class example, I don't think is actually going to be to your benefit. So, so yeah. Okay. In terms of the topics, the topic coverage will be from lecture 1 to lecture 10, okay? And lecture 1 was really just sort of an overview of fundamentals. But if you want a specific breakdown, here's your breakdown, okay? So for the fundamentals, make sure that you understand classical motion. Make sure that you understand Newton's 3 laws. Make sure that you can compute the weight of an object. So if I give you its mass, can you compute its weight by multiplying by gravity? Be able to convert units and perform dimensional analysis as appropriate. I will tell you that the requirements for that on the exam will be minor, okay? This is not a unit conversion exam, okay? I will say this, if I was teaching chemistry, I'd probably throw something on the exam just for that, because I think that's, in that like science, it's much more critical. In here, like if everything's in newtons or if everything's in pounds, unit conversions don't really come up that much. Make sure that you can employ concepts in algebra and trig. And really, I think by now we're aware that trig is really the star of the show in terms of the math that we've been using so far. The big star of the show is particle statics. Number 1, vector properties. Make sure that you understand vector properties. How to add vectors using graphical approaches, trigonometric approaches, or adding by vector components. Okay? Make sure that you can apply equations of static equilibrium in 2D and 3D for concurrent force systems. And that's basically it. So adding vectors and static equilibrium, whether it's 2D or 3D, that's basically what we've been doing for the past 10 lectures. Okay? Remember, in 2D, the first thing we did was learn how to add vectors, and then we said, okay, now let's apply equations of equilibrium. Let's make sure that the sum of those vectors are 0, so what are the unknowns need to be in order to achieve that? And same thing with 3D. Now, everything left in this slideshow is meant to make your life easier in the construction of a formula sheet. So basically what I did is I took the greatest hits from the past 10 lectures and threw them on a single slide, so our single slideshow. So things like fundamental equations, like here's gravity, here's our base unit systems, here's what a Newton is, here's what a slug is. Trig, like, trying to take everything that's needed in trig and put it all on one slide to make your life a little easier. Base definitions of trig functions, make sure that you can convert between rectangular and polar. Make sure that you can do law of sines, law of cosines. The basics of vectors, the idea that vector addition is commutative. P plus Q is the same thing as Q plus P, that it is done graphically. What is the I and J vector? What is the K vector? How do you describe vectors using IJ notation? Okay. I really do like this table because I think that everybody would agree this one slide contains like everything. Yeah, I mean, it's basically all there. That in 2 dimensions, this is how we describe a vector. This is how we describe it in 3 dimensions. This is how we compute the magnitude of a vector, just Pythagorean theorem. Here it is in 3D, just throw another term. How do we compute the resultant, or how do we add vectors? Just sum up the x and y components, or the x and y and z components. Here are the equations of static equilibrium. And then here's orientation of vectors. I really like that slide because I think that one slide includes like every formula necessary under the sun. The one thing that I didn't include here, but might actually be valuable for a formula sheet, is maybe some instructions on 2x2 and 3x3 equation solution, but I didn't put that here because I don't know what calculator you're using. I may know how to do it on Casio, but you know, you might not be using Casio, you might be using something else. Again, I don't really care what calculator you use, provided it doesn't have a Wi-Fi connection. As long as that's the case, you can use whatever you want. So, all right, not a laptop or something like that. Okay, what I'm going to do now is turn it over to you. We can do whatever you want. You got a homework problem you want to look at, got an example problem you want to look at, a concept you didn't understand. This is your time. Whatever you want to talk about. Yes?
Okay, so remember the homework where you had to give us like a hint?
Was that the Poli problem?
Yeah, like where we had like the 2p for one vector and then 2
Yes.
for another. Should we like really focus on that? Like, is there going to be something tricky with the hints like that?
Let me say this. The homeworks, I think, are slightly more challenging than the exam. Slightly more challenging. I'm not going to say the exam's a cakewalk, but I do think I'm pushing you a little further on the homeworks than I would on the exam. That's going to be my best answer.
Okay.
Okay. Well, let me, you, then you. All right.
Can you go over how to find the distance vectors in the previous, like the most recent homework?
2-7?
Yeah.
Sure. So the best thing that I would do is, so whenever we're looking at distance vectors, this is just sort of the way that I do it. I don't know about y'all. I think it's easier to do this. The first thing that I will do is I do not look vector by vector. I look x, y, and z, if that makes any sense. Like I do x first, then y first, then z first. So for example, I have vector AB, AC, AD. Along the y-axis, they're going, does everybody see that they're going up 600 newtons? Or sorry, 600 millimeters. So 600 is the term on every single component, or y component. Does that make sense? Okay. Now, in terms of the x and z axis, if you want, one way of looking at it, can I draw on this? Yes. Is to try and do this. So if I'm in a helicopter looking down, right? So the x-axis is going like this, the z-axis is going like that. Does that make sense? Like if I'm in a helicopter looking like that. So if that's the case, this is point A. And then maybe what I'll do, hold on, I'm sorry. Hold on. Maybe what I'll do is I'll say, okay, let's see. So AC, AC lies along the x-axis, but AC is sort of like that, right? So, for example, if we look at AC, the x is 0, the z is negative 320, right? because the z-axis goes like that, right? But from A to C, we're going like this way, right? So what I'm saying is if we're looking at this up and down, C is going to be like that. B is going to be, let's see, B is going to be along here. So negative 450, nothing there. And then AD, D is going to be like that. Okay? Does that make sense?
Well, how do you know that C has no X?
I'll admit that is kind of difficult to see, but what I'm saying is, like, here's the coordinate system. So you can see that that's going through like this, and it's just going along the Z. It's going along parallel. Does that make sense? I will admit it's kind of difficult to see. And I'll tell you this. I'm not trying to trip you up optically on the exam. Okay, does that make sense? I'm not trying to do that. I won't do that to you. I'm not going to tell you what I'm going to do on the exam, but optical issues there, it's not a problem. I'm just going to leave it at that. You had a question?
Remember like the example that you posted after class? It was like on lecture 8 because you wanted to tell us about the hint for the homework instead.
Oh, yes.
Yeah, I looked at it, and I was just confused about like how we knew where that extra F rod force came from.
Oh, okay. So here's what I was saying. Okay, so here's the example. If I look at this point, okay, the example shows that there's a force this way and a force this way, right? Okay, but just think about this from an equilibrium standpoint. If all there is a force this way and a force this way, then it's just going to go up, right? The rod has to hold it down. But what I'm saying is for the purpose of the problem, it doesn't matter.
Yeah.
I'm saying there has to be something there. I just don't really care what it is. That's what I was saying. Does that make sense?
Yeah.
So if you go like into the description of the t vector and the p vector, yeah, because like here's the thing. If I were to add the rod vector, it would be some 0 here and some component here, and it wouldn't change what p is all I'm saying.
Yeah, I ended up working it out like that just to like show myself. Like,
Yeah, it wouldn't matter for this problem. So. Did you have a question? Yes. Did you?
Oh, no.
Oh, okay. I thought I saw you right here. I'm sorry. Don't hesitate. This is your time. So, here's the thing. If you're sitting there and you got a question, you're like, I'm afraid to ask this, I guarantee you when you ask it, there's going to be 20 eyes going, oh, yeah, I wanted to know that too. So don't hesitate. Okay, this is your time. So.
Okay, so from our lecture problem, it was lecture 8, example 2.
Yes.
And this is like a silly little question, but just to clarify for myself, we ended up having like a drag force, and the only thing like from the picture was that flow. Like, is that the drag force? Is
Yes,
the flow?
that's what that is. The idea is that the water is, so there's a boat in a channel. The water is flowing, so it's yanking the boat that way. There's a force that's wanting to carry the boat in that direction. So, you could call it F sub flow. But yes. The main purpose of this example was to show you that this is a 2D equilibrium problem. And if you want to solve using a 2x2 system of equations, you can do that. Or you can sort of like just look at this and realize that if you did this one first, there's only one unknown. So you can solve this one by hand and then plug that value into here and not have to break out a 2x2 equation solver. That was the purpose of this problem. It was because one of the unknowns was along the axis. So. We're going to have stuff like that pop up all the time later when we do truss analysis. That's going to happen all the time. I'll say one thing. I know that probably some of the very earlier assignments about graphical and trig addition were kind of tricky. right? And we did it that way because that's where we first developed a foundation for vector addition. And then we said, well, you know, if we describe vectors with I and J, we can add a bunch of vectors a lot more easily, right? So here's a common question I will get about, am I going to tell you which method I want you to use? The answer most likely is no, okay? In other words, you're engineers. I'm not gonna micromanage you. I'm gonna give you a problem, I want the answer. I don't really care how you do it. So if you have a problem that you could solve using a graphical approach, or you could solve using an IJK approach, and you prefer to use the IJK approach, go right ahead. I'm not going to tell you you must do the problem this way. I'm not that guy. It's not who I am. That's a common question. I will say this, in the interest of being completely honest, there are 4 exams in this class. I've taught this class a number of times. This one isn't the hardest. This is not the hardest exam. And I'll go ahead and tell you which exam students think is the hardest. It's 2. It's not this one. So I'm not telling you that to scare you. I'm more telling you that now to sort of ease your mind that of the exams we do in here, I don't think this one's the most difficult. Moments on exam 2 does tend to be a little bit more challenging because there's vector multiplication as opposed to vector addition, and that is a more just intensive operation than vector addition. There's no way around it. Like, it takes longer to R cross F than it does to just add 2 vectors. I can't get around that. What I can do is try and shorten the length of the problem to make the problem more doable, but it is what it is, you know. So I'm telling you that more right now to sort of set your mind at ease, if that makes sense.
For 2x2 and 3x3 equations, is there a reason to not do substitution? Because I prefer to do substitution just because I see everything happen.
No, there's not. Let me say this, though. That's a good question. So my answer to that would be looking at this problem. This is the last in-class example that we did. If you wanted to use substitution for this, you would be more than welcome to do it. There's no reason that you can't. I just think it's a little messier with the fact that the decimal values, there's a lot of like decimal carrying over. I think that, personally, I think you can do this problem faster. This problem, I think you can do it faster using a 3x3 system. Whereas the homework that you all just turned in, I think you can do that one faster with substitution. But that problem's different than this one. So that would be my answers. I think that it depends on the problem. I think for this one, a 3x3 system made sense. Homework, maybe not so much. What I would say is, if you have a situation where, let's say you have 2 equations and 2 unknowns, and both variables show up in both equations, it's probably faster to do a 2x2 system. But if you had 2 equations and 2 unknowns, and one of those equations only had 1 variable, solve and substitute. It's a lot faster. That's what I would say. How's everybody feeling about the exam? Are you nervous? Are you comfortable? Like, and maybe what I'll ask is, if you are nervous, what are you nervous about?
I'm nervous, like, to figure out, like, when I see the problem, like, which type of set of steps to do. I don't know, like, I've been reworking out the problems, and I do things, like, by steps and, like, in order, and, I mean, I don't know. I'll study and figure it out, but...
Here's what I'll say. I mean, we've really been doing 2 classes of statics problems. Class 1 is just, here's some vectors, add them up. Class 2 is determine unknown vectors so that the sum is 0. That's basically what we've been doing. So it's, I mean, I don't think I'm revealing anything on the exam by saying the problems that you're going to get is going to be like in one of those 2 families. So like, for example, if it's a resultant problem, then a resultant problem is, here's some vectors, add them up. Now you have a resultant vector, and you can determine properties of that resultant vector. What's its magnitude? What's its direction? But that's really what you're doing. Describing some vectors, adding them up. Whereas if it's an equilibrium problem, you're going to have known vectors and unknown vectors, and then the goal is usually to find those unknowns. So it'll still be adding some vectors, but the steps near the end will be a little different. But I mean, however the problem is structured or worded, I mean, that's basically what we've been doing. So it's going to be in one of those two families. So, but yes, to be clear, I am not trying to trick everybody optically like with 3D stuff. I'm not trying to do that, okay? That's not my intent. So I'm just going to leave it at that. Yes?
You don't have to like work it out, but just for the homework or like most recent one, how would you do that with the 2x2 and 3x3?
So just plug it in the way you would plug in any of the other ones, but you're going to have a lot of zeros, is what I'm going to say. So first off, let me close this because I don't want to leave those notations there. Let me go back here. So here's what I'll say. So like when you get to this point, right, you have 4 vectors that are defined, right? So what you can do is you can say, all right, I'm going to sum this, right? Sum forces in the x direction, sum this, right? Okay? And then what your matrix is going to look like is it's going to be something like this. Like, let's take this first equation right here. So it's going to be like negative 0.6, 0, 0, negative 2.5. Right? So there's going to be a lot of zeros when you plug it into the calculator, right? This one's going to be 0.8, 0.8824, and then like, 3 minus w. Yeah, but there's just going to be a lot of zeros. I don't think it's going to really be valuable. So you could say negative 1 if w is your unknown, and then say negative 3. And then here you can say 0, negative 0.4706, 0, negative 1.8. But again, there's just a ton of zeros, right? So what I'm saying is you could probably solve this equation, take that value, plug it into a later one, and just chug it out that way. That's what I'm saying. So, but I think my big point is just look at the problem. There's probably a faster way of doing it, a more efficient way. Close this. Does that make sense? I will tell you this. There will be both 2-dimensional problems and 3-dimensional problems. But again, I am not intending for the exam to be a time crunch. I really don't think it will be.
Is there anything on the exam that's commonly, like, most people get wrong? Or is it just kind of even?
That's a good question. Interesting. This is the best answer I can give you. Okay? I'm going to give you 2 answers. The first is read the conceptual questions. Like, read them and don't just blow through them. Okay? They're not hard, but it's really easy to just answer it. Like, they're not worth a lot, right? The short answer conceptual questions, they're not worth a lot. But it's really easy to just read them and not, like, actually address what it's asking. I don't really want to get too far into it, but I'll just say you'll understand what I mean after I grade it.
But people assume they know what's going to be asked.
Or they read the question and they, this is what he means, but they didn't actually read it, and then the answer was something else. And all I'm saying, there is one particular question I'm talking about. It's not worth a lot, so it's not a big deal. But all I would say is read the conceptual questions. The other thing that I see students like grossly mistake is, remember how I said there's 2 classes of problems? There is just adding vectors up, and then here's a bunch of vectors. What are the unknowns required to static equilibrium? I've seen students just mix up those ideas. Like there's a problem where I give you all the vectors and say, just add them up. And then you're spending all this time trying to find unknowns. That's not what the problem asked. You see what I mean? That's probably the most like fundamental mistake I see students make, is just barreling through the problem and not actually reading what it says. I really try and ensure that I'm not trying to use tricky wording. I'm not trying to word the question in some like confusing way. I'm usually pretty direct. Like, here's the problem, find this, find this and move on, right? So I've had situations where, here's an example. This is an example. Let's say here's a problem and I say find the resultant vector. Here's the resultant vector. And then you go on and try and find the magnitude and find the orientation and the direction. I didn't ask for that, So all you're doing is wasting time when you could be spending that time on other problems. And then you go to this other problem and you suddenly feel like you're in a hurry. It wasn't the problem's fault. It was that you were spending more time on this than you needed to. So like, if you're asking me, like, I know that was a long-winded answer, but if you're asking me like what do students generally get wrong, it usually involves like not reading the question or doing more than the question asked. That would be my answer.
To clear up the part when you asked about the result,
Yes.
so they would give you the magnitude and direction whenever you ask for a result, and you just want like say IJK for that.
Yeah, if I ask for a resultant, that's what I'm after.
Only
But okay, let me qualify that. Okay, if I ask for a resultant in IJK notation, that's what I'm asking for. But if I ask for a resultant like with some vector with some angle from the x and y axis, then I'm asking for magnitude and direction. You see what I mean? All I'm saying is don't take it further than what you need to answer the problem. That's what I'm saying. Does that make sense? Yes.
Are pounds the only exception to when you don't need it for newtons?
Yeah, because a pound is a force. A kilogram is a mass. So multiplying a kilogram times 9.81 meters per second squared will yield a newton, right? But the flip side is if I gave you a mass in slugs, you would need to multiply that times 32.2 to get it into pounds. That's a good question. So you like that. Let me give you let me address something about that real quick. So there might be a problem where let's say I write a problem and the forces are in kilograms. Let's just say I do that, and you do the problem 100% exactly correct. You just forget to multiply by 9.81. If that's a 30-point problem, that is not a 20-point mistake. You see what I mean? It's a mistake, and I'm going to deduct for it. But it doesn't invalidate everything that you did on the exam. It's going to be a deduction, but it's going to be reasonable. Is what I'm saying. I'm not trying to I'm not one of those all or nothing. Like, oh, it's wrong, 30 points off. I don't do that. So it takes me a while to grade exams as a result. Like, we do this exam on Monday, it will probably take me a week to get it back here for that reason. So. I will. Here's let me see something. Bear with me. There's if I have it on here. I was gonna see if I knew what the average on the exam was last year. I don't know if I have it on here. I usually when I taught this class in fall of 22. I didn't teach it in fall of 23. But I didn't do this exam, but I did a similar exam, and I usually try and tell you what the average is. The last time I taught this class, I think the average on this exam, don't quote me on this, but it was probably 70s to 80s. Like, it wasn't, like an average of a 53. It was not that at all. Pretty normal standard exam. I would again, if there's an exam that I think is going to be somewhat challenging, I'll tell you. And I think exam 2 is the most challenging. I think that you're going to think this is crazy. One of the easier exams, I think, in here is the final. I think the final is actually, and it's comprehensive. I think it's actually easier than you'd think. So I think this exam's about in the middle.
This was probably in the syllabus, but does it get curved at all?
Sorry, what?
Will it be curved at all, like depending on results?
I have been a professor for 10 years, and I hear this term curve. I don't really, nobody's ever told me what it means, though.
It's like you make the highest score or like the average of like the top 5.
I'm being facetious.
Okay.
No, let me say this. Okay, let me address that. I'm being facetious, but in all seriousness, I'm really diligent to ensure that my deductions are fair, but I don't curve. Okay, I've been doing. Let me say this though. I've never really had gross complaints about grading non-exams. I really, so like, let me give you an example. I don't grade your exam, then her exam, then his exam. I don't do that. I grade problem 1 for everybody, then problem 2 for everybody. So like when students ask me like, do you know how I did on the exam? I have no idea. I know how problem 3 did. I mean, but the reason that I do that is because if I take something off for you, you made a mistake, and then you make the mistake. I don't want to take 5 points off for you and then 12 points off for you. That's not fair, right? So I do that to ensure that the deduction is consistent, right? So but yeah, I don't curve as a result. Like my way around that is I'm really thoughtful on my deductions, that I really try to ensure that you get what you earn. So yeah, but I don't curve. So there is an opportunity for some very slight bonus points at the end, but I've never really had anybody complain though. So. How are we feeling now? Better? Worse? It's okay if you feel worse. Tell me, and we'll try and address it. So, I'd rather know. Any other questions? Any other assignments or problems or concepts that sort of tripped you up? Was this helpful? Okay. Good. Going once, going twice. A couple final things before we leave. So I have class in here for right before, so I will probably end that class a little early so that everybody can come in. I will start right at 11 o'clock. Okay. We will put a timer on the screen. Are we going to do the princess timer? Are we going to do the princess timer? Okay, we'll do the princess timer. If you were in CAD last semester, you remember the princess timer. We'll go till 11:55. Okay, I have got to stop it at 11:55 because we got another class coming in. Okay. Don't forget formula sheet, calculator, straight edge. Although it's not really a big deal. One thing, the exam is formatted so that there should be enough room on the exam to write. Like you should have plenty of space to write. You can write on the back. You shouldn't need any extra paper, but if you need some, I'll bring some. And calculator, all that. And I will bring up the code one more time, and I will see you on Monday. That's all I got, everybody.
Can I use 2 different calculators?
That's okay. I got no problem with that.
Because I'd rather use